The universe, a vast infinite tapestry, where every event, every moment, is governed by unseen forces and higher principles. It whispers in the silent depths of eternity, guiding us with subtle signals and cosmic rhythms that shape our reality. In this grand symphony, timing is everything, an intricate dance of energy, intention, and universal law. To ignore these sacred harmonics is to invite chaos and cost, sometimes millions of dollars, and sometimes the very success of a mission. By now, I had amassed enough evidence and statistical significance to demonstrate the validity, power, and value of my advisories. Yet nothing changed the attitude of the scientific and space communities. They refused to accept my insights, and I continued my climb up the metaphorical mountain alone. They wouldn't let me be part of their team. I was eager to contribute, but they believe they hold exclusive control over the truth and see no reason to include others. Their new defense? That my desire for uniqueness and individuality had no place in launch teams. That there is no I in team. That reminded me of an epic quote from the Minecraft movie. There's no I in team, but there are two in winning. And I was winning every time. Jokes aside, I published another advisory for the now rescheduled June 22nd launch. This time, it was even more detailed and precise. Since they were clearly triggered by my characterization of their launch times as inauspicious, I decided to flip the script. I chose to put lipstick on the pig. Here's what I shared with these children. Congratulations. You are likely to succeed if you address the anomalies that are inevitably going to manifest. And so, here it goes. At 11:39 a.m. local time on June 19, 2025, I issued a Muhurta forecast for Axiom-4 that identified the International Space Station, not the Falcon 9 or Dragon, as the mission's principal risk source. The analysis flagged three station-centric concerns: a likely iodine uptick in the potable water loop, emerging microbial or fungal pockets in several rack areas, and the downstream payload handling complications such environmental instability can trigger. The details are as follows. A fresh Muhurta scan rates 0342 AME-DT on 22 June as moderately auspicious, a decisive upgrade over the 19 June window. The timing supports an orderly countdown and clean ascent, yet it also flags a band of mid-level risks that flight controllers must keep on their consoles. The envelope of potential failure modes is as follows. Not every anomaly must occur. This is the spectrum most likely to manifest in some combination. On-time liftoff and nominal ascent. Probability equals 1.0 certain. A flawless T0 is forecast. Falcon 9 Block 5 should leave the pad to the second, sail through max Q, and land its booster on the drone ship. Residual thermal excursion alarms. Probability equals high. Retuned chill down has likely removed the worst hotspots, yet brief thermal excursions could still nudge engine or second stage temps into caution between T-10 minutes and SECO. Expect amber red telemetry blips and quick throttle backs, no RUD foreseen. Avionics/electronics glitches. Probability equals high. Risk of momentary sensor dropouts, bit flips, or docking LiDAR resets. Extra byte cycles, clean power bus checks, and a ready reboot script are the smart hedge. Solar radiation exposure, X-class CME threat. Probability equals high. The model hints at a possible X-class CME inside the plus 48-hour window. Dragon/ISS must be ready to enter storm shelter mode. Crew strapped in, non-essentials powered down, and GOES proton data monitored. Debris interaction, probability equals medium-high. Journey corridor crosses space with debris fragments. Minor flakes or plume-shed debris may come in contact with Dragon. Critical impact odds remain low, but continuous CARM/CAM is advised. Docking interface challenges, probability equals high. Dragon's nose cone latch or IDA-3 alignment pins could need 2 to 3 approach cycles for a hard seal, requiring use of additional propellant. ISS potable water, iodine spike, probability equals medium-high. After berthing, station loops might show iodine a few parts per million above spec. Cartridge swap or bypass could be required. Biological contamination, fungal growth. Probability equals medium-high. Certain ISS modules and racks are candidates for visible fungus. Early surface swabs and sporicide wipes advised. Payload scope adjustment. Probability equals high. Several low-priority experiments were likely offloaded to preserve schedule. Food packs mostly refreshed, but a few legacy dry pouches might still be present and carry mild spoilage risk. Crew morale and optics. Probability equals medium. ISRO's 24/7 push has steadied spirits, yet any hiccup, especially during docking, could reignite scrutiny of pilot procedures. A smooth approach equals PR win for Parrot. A wobble invites headline noise. Overall verdict, launch proceeds. Falcon flies textbook, Dragon docks and mission goals are met, provided teams stay sharp on thermal control, avionics resilience, solar weather, docking hardware, and station consumables. Congrats in advance to SpaceX, ISRO, NASA, Axiom Space, and the entire international flight community. I did my best to soften the advisory and make it more acceptable. Barely hours after I issued this advisory, NASA faltered and delayed the launch with a vague statement about interconnected systems and recent Zvezda repairs. It was laughable, and the lack of transparency spoke volumes. A clear echo of the risks I outlined in my advisory. The gap between my forecast and their decision? Just 249 minutes. Whether they scripted the hold or simply reacted to the advisory, the timeline now stands as undeniable proof of predictive precision. This validation extends an unbroken sequence of 10 publicly archived Muhurta forecasts that have all been borne out by events. The list includes the Peregrine propulsion failure, the Starship 2 breakup, the Starship 3 success, the New Shepard NS-24 scrub, the Axiom-4 delay, Chandrayaan-3's flawless ascent, and 2 separate calls inside the current Axiom-4 campaign, the 11th June liquid oxygen leak, and the 19th June ISS-driven hold. 10 successes in 10 trials produce a perfect point estimate. A strict Klopper-Pearson exact binomial calculation places the 95% confidence interval at roughly 0.69 to 1.00. Waiting for the added complexity of crewed missions lifts the forward-looking probability of accuracy into the 0.90 to 0.95 range, well beyond the reach of conventional schedule models or weather algorithms. Predictive power matters because delay costs are real. NASA's audited figures for crewed Falcon 9 missions show that each unscheduled day on the pad absorbs roughly $1 million in range fees, cryogenic reconditioning, hardware retests, and continuous staffing. The present Axiom-4 pause has already diverted between $10 and $25 million from project reserves. Capital that would still be on the ledger had the manifest aligned with the Muhurta window highlighted in advance. Scaled across a year of global launches, avoidable timing errors drained 9-figure sums. Additional corroboration has emerged since the Axiom-4 hold, strengthening 2 other high-probability alerts in the original forecast. First, in the same temporal corridor reserved for the delayed Axiom-4 departure, SpaceX's highly reliable Falcon 9 Block 5 encountered a last-minute abort on its Starlink 1023 mission. At T-1 minute 57 seconds on 22nd June, the launch director halted the count because of a poor signal from the flight termination system, an avionics fault that matches the high-probability avionics/electronics glitches warning published in the Muhurta brief. Second, at 2350 UTC on 19 June, NASA's Solar Dynamics Observatory recorded an X1.9 solar flare from sunspot 4114, causing a Pacific-wide shortwave radio blackout and destabilizing a magnetic filament that may yet drive a coronal mass ejection toward Earth. This event corroborates the forecast's high-probability solar radiation exposure X-class CME threat advisory, which urged Dragon ISS planners to prepare storm shelter procedures and monitor proton data. The Starlink abort and the X-class flare provide independent confirmation that the same temporal window carried elevated avionics glitch and space weather risk. Exactly the compound threat profile the Mahertha model identified. Rockets, no matter how advanced, ultimately bend to the universe's timetable. Precision timing remains the surest path to mission success and fiscal discipline. Despite my repeated successes, I've noticed that the general public often perceives my forecasts as negative. Well, I can't predict auspiciousness where it simply doesn't exist. I'm in the business of delivering accurate outcomes, not comforting stories. If I were here to tell you only what you want to hear, I wouldn't be a good astrologer, just a storyteller. To lighten the mood, I decided to share a sports forecast before issuing yet another advisory for the again delayed Axiom launch. I saw in the news that the NBA Finals was scheduled for June 22nd, 2025, between the Indiana Pacers and the Oklahoma City Thunder. And of course, no prizes for guessing. I was right again. And once more, the silence from the other side continued.